So now, after all the things that we've talked about in trigonometry, we've finally get to lesson 5, which is arc length. Arc length. Now, this is something that you already know, right? I know that you've seen this before. And if you haven't, it's a good time to talk about it now, okay? If I ask you, if this is a radius r, how do you calculate, or do you remember how to calculate the distance around the circle? Do you remember the formula? Circumference. Very good. It's called a circumference. Okay. Circumference. So circumference is equals to what? 2 pi times r. 2 pi times r. Right. Okay. 2 pi times r. Now, I'm going to go here. What's 2 pi? 2 pi is the rotation from here all the way around. And then the r is the radius. That's basically what this arc length is. The arc length is not the whole circumference of the circle, but what if you just want to do just this piece? What if you just want to know how long is this piece here? Right? That's not rotating 2 pi, but it's only rotating pi. So that ties into this. So the formula S is equals to pi times r is the formula to figure out the arc length. It's part of the circumference only. Part of the circumference. Where theta is the central angle, is the angle in radians, and r is the radius. Okay, so that's a formula. S is equals to theta times r. So, example 1, determine the length of the arc that subtends a central angle of pi over 4 in a circle with a radius of 6 centimeters. So, they're saying, what is the length of the arc? Now, let's take a look at this, pi over 4. Can you imagine what pi over 4 looks like? Okay, you're thinking about degrees and you're converting it in your brain. When we looked at this, this is from here to there, right? So what we're really wanting is, how big is this? Now, the bigger the radius is, the bigger that arc is going to be, right? So r is 6. So S is equals to theta times r. So theta, the angle, is pi over 4. So pi over 4 times 6. So this one is equal to, we can multiply and reduce at the same time. So this is going to be 3, this is 2, so it's going to be 3 pi over 2. So that means if we have a circle with radius 6, and like we put a tape measure around it, it's going to be approximately 3 times pi over 2. Now this is the exact one, 3 pi over 2. Okay, is that good? Take a look at example number 2. It's going to be a fast one. So determine the arc of a length with a circle that has a central angle of 2.3 radians and the diameter of 8 feet. Now this is a circle, diameter of 8 feet. Okay, they kind of do something like different ways of asking the question. If the diameter is 8 feet, how big is the arc length of a circle? They're telling us the angle is 2.3. So S is equals to theta times R, radius, this is the radius. So theta is 2.3. The radius is 4, right? Because the diameter is 8, that means the radius is 4. So that's going to be 9.2. 9.2. Oh, I forgot something. 9.2. We want to, what's the unit for this? Okay, remember the arc length is the length. When you're measuring the length, how are the length measured? Meters, centimeters, feet. Then this one is 8 feet, so that's 9.2 feet. And I gotta go back in here. What's the unit for this? It's 3 pi over 2 centimeters. Because it's a length, right? How long is that arch or arc? So, sounds good? Yeah.
You use the 4 because the half of the diameter is 4, right?
Half of the diameter is 4. Yes, that's correct. Good? Pretty easy. Don't you wish it's on our test tomorrow? Okay. Example number 3. A circle has a radius of 7.6. What is the measure of the central angle for the arm length of 2.4? Now they're saying I call it the backwards question, because now they're telling us the arc length is 2.4. We're solving for the angle. So how far is that angle going to turn? So S is equals to theta R. We're going to solve for theta. So if you're solving for theta, what are you going to do? S over R. S over R, correct. So theta is equals to S, that's 2.4. R is 7.6. So that means theta is whatever that is. 2.4 divided by 7.6. Okay. So about 0.32. So 0.32. We'll just say round it off to 2 decimal places. 0.32 what? Radians. Yeah. We're talking about the angle. The angle are measured in radians. Okay? That's a unit. Okay. Any questions there? Not bad, right? Like, let's take a look at example 4. Determine the length of the arc. Determine the length of the arc that subtends a central angle of 25 degrees in a circle that is radius of 14. Now, okay. Before we even figure this out, what do we have to do? Do you see some kind of a problem in here? Yeah. So this 25 degrees is not the right measurement that we want. We need to have in radians. So here first, convert theta in radians. And of course we know how to do that. So 25 degrees and brackets. We're gonna get rid of the degree. So we're gonna put 180 in the denominator, pi in the numerator. So that becomes whatever that is. So 25 pi over 180. So S is equals to 25 pi over 180 times 14. Now we can, we should be able to reduce that. Okay. What's the common factor between 25 and 180? So if we divide by 5, then that would give us 36 times 14. 36 and 14 have a common factor of 2. So the 2, that becomes 7 and 18. So that's going to give us 5 times pi times 7. So that's 35 pi over 18. 35 pi over 18. Now, we look at that. Can we reduce that still? I don't think so. What's a unit for this? Centimeters. Very good. Because this is the arc length. Arc length, and the length is measured in centimeters. Good. Example 5. Central angle is 5 pi by 8. Creates an arc length of 5 meters. What is the radius of the circle? So S is equals to theta times r. So we're looking for a radius. So how can we solve for radius? S over theta. Yes. S over theta. Okay, so I'm just going to put that over here. S is 15 divided by 5 pi by 8. Now this becomes like, it's called complex fraction because a fraction has a fraction in it. So R is equals to, but that's okay, we know how to do this. Dividing is the same thing as multiplying reciprocal, right? So it's going to be same thing as multiplying 8 over 5 pi so we can reduce 15 and 5. That's 1 and 3. So 3 times 8, that's 24. And then that's just pi at the bottom. 24 over pi. And what's our unit? Meters, yes. Because the radius is the length as well, right? But this is now fun. Now that we've talked about those things, the question becomes even more, I guess, applicable to real life. It says here, how far does a bicycle wheel travel after 100 rotations? So it rotates and rotates, and the wheel is 34 centimeters in diameter. So every time it rotates, right, which is 2 pi, it pretty much covered that S is equals to pi times r distance. Okay, so if you're bicycling or driving, so S is equals to pi times r. Now, but the thing is, diameter is 34, so that means radius is 17 centimeters. Okay, so it's 100 rotations. Now, if it's 100 rotations, how many degrees is that? 100 times 2 pi. So this is not this is not the angle. This is how much it rotated. It rotated 100 times, and in each rotation, think about it. Each rotation it covered 2 pi, right? So I'll write a little note here. Note: 1 rotation means angle is 2 pi. So if there's 100 rotations, that means, so angle must be 2 pi times 100. It's going to be 200 pi. So now we're ready, right? So theta is equals to 200 pi times 17, because 34 was our radius. Okay, let's do that one. Okay, so it would be 3,400 pi. And what's the unit for this? Centimeters. Centimeters. Okay, is that good? Next, last two. We should be able to finish this. The pendulum of the clock is 42 centimeter long. Okay, now I know sometimes it's hard to visualize this. What's the pendulum of the clock? Right? It's like, if this is a clock, it swings back and forth, back and forth. No, the clock doesn't go all the way around. The pendulum doesn't go all the way around. It just swings back and forth. So the pendulum of the clock is 42 centimeter long. And if it swings at an angle of 32 degrees, so this is still 42, right? So it swings at 32 degrees. Determine the total distance traveled in one complete swing. Okay. So the problem here is that the angle is not in radian, it's in degrees. So what we need to do is we need to figure out the angle first. So 32 degrees would be pi over 180. Okay, so 32 and 180, that's the theta. And then we know the radius is, how do you know that this is 42 is radius? Not the diameter. Yeah, it's just a pendulum where it's back and forth, right? This is the center, right, where it's attached to, and it swings away, right? So S is equals to theta times R. So theta is whatever this is, 32 pi over 180 times R. R is 42. So, well, we're not going to leave our answer like that. 32 and 180. 32 divided by 4 is 8. 80 divided by 4 is 8 pi over 45 times 42. 42 and 45, it's going to be divided by 3, so that's 14, is 15, so that's going to be 8 times 14 is 112 pi over 15. Oh, I did all that for nothing because it says rounded to the nearest tenth. So we'll just figure that out, rounded to the nearest tenth. Twenty-three point five centimeters. Is that okay? Okay, let's see here. A center pivot irrigation system traces out a circular path. And as it irrigates farm fields, one system has an arm 36 meters long, and the speed of the end of the arm is 3 meters per minute. In radians, through which angle will the arms have rotated after 30 minutes? Now, let's just amp up the question here. So here, let's see. I like the visual, as you know. So this is the pivot, the center. And one system has an arm of 36 meters long, so that means the radius is 36 meters long, right? So this is like that, and it kind of sprays water as it goes around, right? Around like that. And then it rotates. One system has 36 meters. The speed of the end of the arm is rotating 3 meters per minute. So it rotates 3 meters per minute. In radians, through which angle will the arm have rotated after 30 minutes? So if it's turning 3 meters per minute, 3 meters per minute, how many meters would have rotated after 30 minutes? 90, right? So you know it's going to be 3 meters per minute, and then times 30 minutes. So minutes cancel, so that becomes 90 meters. So it will rotate 90 meters. Rotated 90 meters. So what's a 90 meters? That would be our S value, right? Rotated already 90 meters, so theta times R. S is our 90, and then in radians, so we're really looking for theta, right? So theta is equals to S over R. S is 90, radius is 36. So how many radians is that? 2.5? Okay. 2.5, and we already said it's going to be radian measurements. Okay, that concludes that. You do have some assignment questions in here. You have an option for the rest of the period today. You can work on this assignment questions, something for you to practice on. This lesson is not too bad. This is easy in comparison to what we've done before. Or the other option is for you to work at some of the questions on the book, a review question, work alone, work with somebody else, work with me, it's okay too. But yeah, that's how we're gonna spend the rest of our period today. Okay? Everything is Awesome. Yeah, it's good. Okay, so there you go.